Today in class, we demoed the use of math.random. We started it off very simple like this with a little loop that counts from 1 up to something like maybe 25. Put math.random in here. Now, just putting capital M math dot means that somewhere on our computer is a class named math. At the top of that class, I know it says public class math. Okay, that's what that math, capital M, lowercase ath tells me already. I know that's true. The dot random part means we're going into the math class and looking for something called random. Since it has parentheses after it, I know it's a method. Methods are always followed by parentheses. So somewhere in the math class is a method with the following on top: public, static, double, random, and its parentheses are empty up here. Okay, so what this thing does, if I put in an out.println line, prove it, what this thing does is generate a random number in the range, if let's say n is our number, then n is bigger than or equal to 0, or 0 is less than or equal to n, and n is less than 1. It'll be 0 point something, 0.0 up to 0.999. Okay, in effect, not quite, but almost, you could say less than or equal to 0.99999. I can't put enough nines there to really make it accurate, perfect, but that's about the same thing, right? Less than 1 means less than or equal to all those nines there. Okay, and so I run this code, and 25 times I'll see 0 point something, all different, all generated differently. Here I go. And there's 0 point whatever 25 times. Nothing less than 0, nothing above 0.999. Okay, then we started tweaking it. Okay, you need to type along with me, guys. If you're not in class especially, and if you were class and I went too fast for you, type along with me. If I say 2 times that, then, well, what's 2 times 0? Just 0. So my low end of the range is still 0. 2 times 0.999, 2 times 0.9999, that's 1.9999. So I'll get a bunch of numbers from 0 through 1.999. Nothing less than 0, nothing above 1.999. You need to have typed this in like the rest of the class did in today's lecture. So if I go times 10, 10 times it, 0 up to, well, what's 0.999 times 10? 9.999. Still all decimals. Okay, that's how we started off class today. And then we said, well, what if we don't want decimals? We just want to get some integers, some whole numbers maybe. So we can cast. Let's go back to just math.random. If I cast this, recall math.random is 0 point something. If I int it, all it's going to do is chop off the zeros, the decimals, and make it 0, right? If I int it, 0.5 becomes 0. 0.82 becomes 0, and so on. So I'm going to have 25 zeros here, probably some pretty useless code, all zeros. So that's a mistake probably on a programmer's part if she does that. But what you can do is take int of math.random times that 2 again. Now what does that do? Well, this inside part we already saw gives 0 up to 1.999, right? This gave us 0 to 1.999. Take 2 times this and you get 1.999. If I int it, I'm chopping the decimals off, so like 0.7 becomes 0, but 1.7 becomes 1. So I'll get a bunch of zeros and ones. There they are, a bunch of zeros and ones. Okay, now we played with that code a little more by letting it simulate flipping a coin. We said, complete this loop so that it simulates flipping a coin 25 times. Each flip display heads or tails. So we arbitrarily pick a number, either 0 or 1, right? This here gives zeros and ones. We arbitrarily pick a number for heads and pick one for tails. And so maybe all these ones become heads and all the zeros become tails, and we'll have simulated it. So we say int coin equals that. Okay. Now coin contains a 0 or a 1. So if coin equals, what do we say, 1, then it's heads. Else out.println tails. So 25 times I should see heads or tails. Let's see what I have. Extra parenthesis, I think. Yeah. A bunch of heads or tails. Okay. Then we said, why don't we flip it 1,000,000 times? 1, 2, 3, 1, 2, 3. And let's not display heads and tails, but let's count the number of heads and tails. So num heads plus plus num tails plus plus. Just going to count how many come up. So again, students in class today tried something just like this in class before I gave them the answer. And so down here we say out.line and good. So a little over 500,000 heads and just a little below 500,000 tails the first time. Next time through, it might have more tails than heads. They're really close, being 50.0%. They're right on. And you can see it's up or down, heads or tails, but right on. And then further, what if I said display the percent? So percent heads and percent tails. Then you would take num heads divided by 1,000,000, and then times 100. Now, num heads divided by 1,000,000 is going to be 0 all semester long, right? So we got to put 0.0 here. And the same thing for num tails. And then we'll see our percent, both of them being right around 50, get it right. Okay, right around 50% there. That's good. Okay, and then finally, the very last thing in class today was we started rolling a dice. Okay, let's go back to looping 25 times. Okay. A dice, a normal dice, has 6 sides. So it simulates rolling a die this time. So we want to have 6 different numbers. And so let's say die, singular of dice is die, D-I-E. So you take it times 6. Let's just see what we get. Out.print line die. Almost done here. Okay, no errors. And whoops, I didn't do my plus plus probably, did I? Didn't do my plus plus. Infinite loop. Compile it. Good. Run it. And I have zeros, 1s, 2s, 3s, 4s, and 5s. Okay. I don't want zeros. Dice don't have a side equal to 0 usually. It's 1 through 6. So the way to do that, to fix that, is just say +1. That turns your zeros into 1s, 1s into 2s, 2s into 3s, 3s into 4s, 4s into 5s, and your 5s into 6s. Okay? So there it is. For homework tonight, I'd like you to roll a pair of dice 1,000,000 times, and then after the loop, display the number of times a 7 was rolled. Also display the percent of the time a 7 was rolled. Okay, I'll tell you right now, the percent should be whatever 1/6 is, like 16.67%, something around there is what it should be. 1/6 of the time, that's the odds. 1/6 of the time, that's the probability of rolling a 7. Thanks so much for watching. Hope that helped. Hope you typed along with me. Slow it down, type it again, and then try this homework problem.